Hi everyone, this is your struggling CS student, and today let's solve another LeetCode problem today. Let's take a look at today's problem. 3289, the two sneaky numbers of Digitville. Okay, in the town, Digitville, there was a list of numbers called nums containing integers from 0 to n-1. Each number is supposed to appear exactly once in the list. However, two mischievous numbers have sneaked in an additional time, making the list longer than usual. So as the town detective, your task is to find these two sneaky numbers and return an array of two containing the two numbers in any order so peace can return to Digitville. Appear twice. 2 and 3 appear twice. 4 and 5 appear twice, I'm guessing. Yep. There's at least two numbers. Nums.length is n plus 2. Okay. Nums of I is 0 to n. The input is generated such that num contains exactly two repeated elements. Okay, so the way I'll think about this is, well, because it's an 1100 rated question, you could use like a set and keep track of the elements that have already appeared. And if they appear again in the set, then you can just add them to the output. But actually, there is a O1 solution in terms of space complexity to solve this problem, and I believe the solution involves the use of bitwise operation, right? So it leverages on the fact that when you saw two of the same numbers together, you actually get 0. So um, at least that's what I learned a few months ago. I've never really put this into practice, so let's walk through an example. Let's say we take we take that set of numbers. So we say 0 saw 3. What do you get? 0 saw 3. So it's like 0 0. 3 is like 1 1. So I believe you get 1 1. So you get 3. And 3 saw 2. Okay. Let's put the sort here. Sort 2, which is like this. So this is 1 and this is 0. Yep. So what do you get? You get 1. So 1 sort 1, you get 0. Right? 1 sort 1, you get 0. Okay. Oh, oops. So after that, you sort 3 again. I believe you get 3. Sort 3, you get 3. Oops. Then you sort 2 again. Maybe not. Maybe I lied. Let's see. 3 sort 2. 3 sort 2. You get 1. Get 1. So what does that tell us? Nothing. Maybe not then. Maybe that's only for like a single duplicate number. Yeah, I think that only works if there's only like a single duplicate number. Hmm. So if let's say you have like 1 1, 3 3, and 2, then you get like this back. Hmm. Okay, so the soaring approach wouldn't work. Um, I'm thinking of I'm thinking of abusing the fact that each element can only be up to n, but then you have two duplicated numbers. Two duplicated numbers. Another approach is to sort them. So if you sort them and then you just keep track of like the current and the next pointer, but then sorting kind of defeats the purpose, right? Because like you get n log n and the space complexity is O(n). Because Python's team sort, then you might as well just use a set. Okay, fine. I'll just use a set then. Uh, so we'll do scene is equals to set. What's it? Oh, sets for none in nones. We have like output if none in scene. Then we do output dot append none. Alright, otherwise we can do scene dot add none. Then you return C output. This should work. Alright, YOLO submit. Okay, yay, it passed. But then again, this was a simple question. So yeah, time complexity is O(n), space complexity is O(n) as well. Let's take a look at the editor. Is there like a O1 solution? Hash table, yeah. Bitwise operation. You see, I was thinking about this. Oh, wow. The implementation is a little bit more complex than I thought. We can sort our numbers with all the numbers from 0 to n minus 1. The result of the sort is the two extra numbers as denoted as y. The lowest differing bit is using low bit equals to y and negative y. Okay, maybe that's like more complex than I thought. But yeah, it kind of makes sense. So like for this particular input, you would sort 0, 1, 2, 3, right? So if you sort it, then you remove this, remove the 1, remove the 2, remove the 3. This is what you are left with. But you will get the result. You'll get 3 sort 2, I think. Low bit, okay. Yeah, maybe this is a little bit more complex. Yeah, I also thought of like abusing the fact that nums of y is only up to n, so maybe like we could have done something with the arithmetic sequence, but let's see. Okay, yeah, nah, there's like so many terms here. Wow. Oh, it's still O(n) and O1. I thought maybe it's like O1 solution, O1 time complexity, but I guess not. Bro, nobody's figuring this shit out, man. Come on. All right. Anyway, yeah, that's it for me for this video. Thanks for watching and have a great day.